Hello, geometry students. This is part 2 of 7-2, Similarity Transformations. We're looking at example 3. Find similarity transformations. Why is ABC similar to A prime, B prime, C prime? And we're talking about this triangle down here, the black and red triangles. But first we need a definition. A similarity transformation is a composition of one or more rigid motions and a dilation. A similarity transformation results in an image that is similar to the pre-image. And if you remember from the other day, we talked about what it means to be similar. And so the angles will be the same, but the sides will be proportional. All right, describe a possible similarity transformation for the pair of similar figures shown, and then write a similarity statement. Okay, we have this triangle ABC, and what happens is it appears to be rotated maybe 90 degrees, which is a rigid motion, and maybe it's about the point C. But then it would need to be translated down and left to point C prime. And you don't have to be so detailed, but I just want you to think about what I'm writing here. So we've had two rigid motions, but then we're also dilating it. So we're going to make it enlarged, and to show an enlargement or reduction, we have to dilate. So we're dilating at C prime to enlarge. And since we had two rigid motions and then we had a dilation, this is a similarity transformation. And to write our similarity statement, we would write triangle ABC is similar, and we use that squiggly, to triangle A prime, B prime, C prime. So that is how we write our similarity statement. All right, I would like to pause the video, and in your groups, I want you to talk about why these shapes, so we're starting with W, X, Y, Z, and how does it become W prime, Z prime, Y prime, X prime? I went in the wrong order. Oh, I see. It did go in the wrong. It went in another order, so you need to say, how did it get to be that shape there? What possible rigid motions happened? Was it rotated, translated, or reflected maybe? So what do you think happened to get the yellow quadrilateral to become the blue quadrilateral? All right, and talk about that within your groups, and we'll be coming around to hear your conversations. Okay, we're on the last page, and example 4, we want to determine similarity. So this is a real world problem that could be used in interior design or just decorating your house. Can the artist copy her sketch to cover an entire wall measuring 15 feet high by 20 feet wide, so her wall mural is similar to her sketch? So she wants to draw this on the wall, and she wants it to fit the whole wall. And so when we're talking about scale and similarity, it's helpful to set up a proportion. So let's see. The 14 inches would be the width. So that'd be how wide is it, and then the 11 inches would be how high is it. We want to compare those numbers to the 15 feet high by the 20 feet wide. So we're going to set up a proportion where, let's see, we want to compare these numbers. I had to think about this for a second, but we want to compare, so I will take the 14 inches wide, and that's going to compare to the 20 feet wide. So that's talking about the width. And then I can compare the height. So we would compare 11 inches to 15 feet, because that's talking about how high the mural is. Now we have a proportion, so we can set this up as two fractions or ratios equal to each other, and we can cross multiply, and if the cross multiplications are equal, then it's a proportion. So we will do 20 times 11, and that's going to be 220, and 15 times 14, and I get 210. So these are not equal if I did my multiplication correct, which means that the picture will not fit perfectly. It's not similar to the size of the wall. So she would have to make some adjustments to her painting if she wanted it to fit. Our last example is example 5. Identify similar circles. Write a proof that any two circles are similar given that circle P has radius R and circle Q with radius S. Prove that circle P is similar to circle Q. And what we want to do is we want to compare the radii. So we're looking at radius R and radius S, and if we were to take circle Q and we said that we got circle Q from circle P, is that a set of rigid motions and a dilation? And we can figure out what the scale factor is by dividing. So if we take the large circle and we divide it by the small circle, those radii show a dilation. So there is a similarity transformation, and this is true for all circles. All circles are similar. And to conclude this lesson, we have our concept summary on similarity. So I'm going to have each person, or I'm going to have 3 people read the words, and then we'll talk about the diagrams as a class.